Question 4 is the function question. So they told you have a function x cubed minus 9x squared plus 15x plus 2. And they want you to find the coordinates where the graph cuts your y-axis. So again, they've told you y-axis. So what you know about y-axis is if something cuts the y-axis, it's basically telling you x is 0. So if you want to find the coordinates where the graph is cutting your y-axis, you are plugging in 0 instead of x. So you're getting the function at 0. Right? So you go 0 cubed minus 9 times 0 squared plus 15 times 0 plus 2. Work it all out, you get 2 as an answer. So your point is 0 for your x, 2 for your y. Part 2, it says verify that the graph cuts the x-axis. Sorry, so you can see better. Cuts the x-axis between x is 2 and x is equal to 2.5 and explain your answer. So your function was f of x. At x is 2, we are getting f of 2. So you plug it all in the exact same way as you're doing above and you get the answer 4. Right? So basically at x is equal to 2, you would have a 0.24. At 2.5 for your x, again plug it all in and multiply it out. You will get minus 1.125. Okay, so your point is 2.5 minus 1.125. So the question is asking you to verify that it cuts the x-axis. So when you're looking at it, you have one point that's above your x-axis, one below the x-axis. So that meant it had to cut the x-axis between those 2 points. And that's it done. Part B is derivatives, differentiation calculus. Right, so it says, hence find f dash of x, the derivative, right, and find the coordinates local max and the local min turning points. So you write down your function, you then differentiate it, which means get the f dash of x. So how you do that is you bring forward the powers of your x's, write it down like you're multiplying, and reduce the power by 1. So x cubed became 3x squared. Our minus 9x squared became 2 times 9, which is 18, so minus 18x, and this x is just to the power of 1. And this one, the power of the x was a 1, so you're just getting 15 times 1, and you don't write down the x anymore. Okay, it asked you to find the local max and min, so after you differentiate it, you then let it equal to 0, right? So let your answer for the differentiated bit equal to 0, and what you're meant to note is that you have a quadratic equal to 0, so that means you can use your minus b formula. So write down what a is. So a in this case is 3, b is minus 18, and c is 15. All right, so write them all down nice and clear, plug them into your formula for the minus b, and then work them all out. Okay, I haven't worked them out because I didn't have the calculator. Okay, but you will get the values of 1 and 5. Okay, and then finally, you plug in those values, your 1 and your 5, back into the original. So you're not plugging them into your f dash of x, you're plugging them into the f of x. So if we get f of 1, plug in 1 in everywhere there was an x, so you get 9, so you get a 0.19. And then you plug 5 in, and you will get minus 23, so you have a 0.5 times minus 23. So from that, you know 19 is higher up than 5 minus 23. So this is the max and this is the min. Okay, and then finally, it asked you to sketch the graph of f. So how you do that is type in your function into your calculator on table mode. You're going from minus 1 to 7, you're going up in steps of 1, and it will give you various different points, and you plot them and you join them. And it says indicate both your turning points. So on your graph, have this, highlight it, and say it is your max. And have this one, which is the bottom of the curve, and again highlight it, and say it is your min. Okay?